I am the professor in this place from which emerge strange things by the name of Julius Sumner Miller. And I will show you now a strange thing which you will be led irresistibly to do instantly because you will not believe me. And yet what I say and do is true. Consider the following. I have here a stick. Happens to be a meter stick, but you could use any stick. Rectangular cross-section, round cross. Indeed, take your broom, your house broom, and cut off the head of the broom and you have a stick. May give you some trouble, but you'll have a stick. Now let us say that this stick is a good stick. By a good stick, I mean it's uniform, homogeneous, and isotropic. Oh, those are pretty fancy words, but they describe the stick precisely as I wish it. So I'm going to do as follows. I'm going to rest the finger on the stick here, and it is so rough. I'm going to rest the stick on this finger, and it is equally rough. And I'm going to support the stick first symmetrically. 80 and 20. The stick is thus supported symmetrically. Now I'm going to push my fingers toward each other, and if the roughness here is the same as here, then the fingers should meet in the middle. Watch, and we shall see it's true. Well, the roughness is not identical, but nearly so. And I am pushing both fingers. I am pushing both, and the fingers met in the middle at 50 centimeters. Now I'm going to do it again, putting my fingers at 70 and 30 symmetrically. And the same result will ensue. Now don't think this is trivial, because this is very complicated. As you will see, I'm going to push my fingers toward each other. Again, I started symmetrically, and the fingers meet in the middle. Oh, says someone, the fellow is a stupid old man. He ought to know it is so. But now, what did I say? I said, but now I am going to support the stick unsymmetrically. At 70 and at 10. Certainly, these supports are unsymmetric. Now I am going to push my fingers toward each other. And the question to ask is, what will happen? Is it not logical, is it not reasonable to say that the stick will tip this way? It is so. The stick will tip that way. But now watch. Watch. Watch sharply. Ho-ho, says somebody, Professor, you are not pushing this finger. I am, because of the paradox of forces we learned about earlier. A force cannot exist alone. They must exist in pairs. I am pushing that finger. No requirement that it move. I am pushing that finger. I am pushing it. I am pushing it. I am pushing it. And now it moves. And the stick did not tip. So there emerges from this place this strange mystic thing of the stick which did not tip. Now supposing I have a smoother thing than my finger. Here is a metal bar, much smoother. I'm going to put it there, and now somebody says, why, Professor, the stick must tip that way. No, no, it will not tip. It will not tip. And I say, that is mysterious to contemplate. The stick did not tip. And we have to ask why it is so, and I'm going to tell you the mathematics. F is equal to mu n. And so, what am I suggesting to you all? That to understand the behavior of nature, one must learn some mathematics, which is not only good for the mind and the spirit, but for the soul.